Populations are important, and one thing that gives us insight into a certain population is population dynamics. This concept explains whether a given population will shrink, expand, or just be stable in the future. Why is this important? Well, using this, we could save endangered species, control pest population, and also track how many humans will be able to join the workforce in a certain year in the future. Population dynamics has mainly three contributing concepts: population regulation, population growth, and demography. My time's up, so these three concepts will be explained by the rest of my groupmates.
As we study how and why populations change in size and structures over time, changes in the form of population regulation become significant due to its alteration of certain demographic processes, which in turn affects birth and death rates. As shown in this mind map, population regulation comes in a pair. One is density dependent while the other is density independent. Density dependent factors intensify as the population increases in size. Examples of this would be competition, which occurs when the number of resources is not enough for individuals. Second are diseases that are likely to cause more deaths as the population increases as well. And lastly would be predation and also waste accumulation. In contrast to density-dependent factors, density-independent factors exert the same influence on a population regardless if it is large or small. Hence, it is also independent of how dense the population is. An example of which, as shown in this mind map, would be pollution and natural disasters such as fires and severe weather. Within a population, there are certain factors that affect its expansion and decline. Demography, as we call it, is the mortality, natality, immigration, and emigration rates within a population. Mortality refers to the deaths within a population. Natality would be the births. Immigration would be the new individuals joining the population. And emigration would be the individuals leaving the population. These factors have a direct relationship with population sizes, as it is quite well known that natality and immigration increase population sizes, while mortality and emigration decreases them.
Population growth determines whether a population will persist or not. Demographic patterns affect population growth. Thus, understanding these demographic factors is crucial to better analyze the changes in the size and composition of every population. Life tables, which focus on the rates of birth and death, can be used to analyze organisms in their different life stages. According to Can and D, the life table records things about the population's life and death, and it basically serves as a summary of what is the possibility that the population's organisms will live, die, and or reproduce in their different life stages.
Survivorship curves are visual representations of the number of certain species that survive as they age. To better understand this concept, let us look at its three types. Type 1 is where humans fall under. Because offspring come in small numbers, they are usually well taken care of and are protected. Thus, death during the younger years is quite a rare occurrence. We can visualize this type in a graph as a straight line that eventually curves downwards, as death mostly occurs during the old age. For type 2, it is observed as a diagonal line that goes downwards. This type of survivorship curve is observed in birds where the number of deaths is almost constant throughout the years. Also, the parent organism still provides some significant care to their offspring. Meanwhile, organisms displaying type 3 survivorship curves tend to produce a lot of offspring yet do not provide enough significant care, so only a small number survives. However, offspring who are able to survive commonly grow to have long lifespans. We can visualize the type 3 curve in the shape of the letter L. The most common example of an organism with this survivorship curve are trees.
Moving on to the population growth in the Philippines. When it comes to the Philippines, it has been reported that the population growth rate continues to be very high. Through the use of various population pyramids, life tables, and survivorship curves, we are given the opportunity to better visualize these data. According to the Philippine Statistics Authority, the country's population reached 109,035,343 as of 2020. The population increased by 8,053,906 from the initial 100,981,437 in 2015. For a population growth rate, or PGR, of 1.63% annually. With this annual trend, the country joins the top nations in Southeast Asia with high PGRs. It is important to take this high population growth into consideration as it is inversely proportional to the economic growth of the country. This imbalance may lead to many consequences, including environmental degradation. As each year passes, the world's population keeps growing. It is essential for world leaders to consider the three concepts of population dynamics, namely population regulation, demography and population size, and population growth, in order to maintain a well-balanced growth and development in their respective nations. Given the scarcity of resources on this planet, continuously high population growth rate will surely have its negative effects. Mass deforestation and overuse of natural resources are already existing effects of this excessive growth. Reducing this growth can help relieve strain on ecosystems and natural resources, make it easier to manage land and water resources, and increase the likelihood of attaining a more fair distribution of energy. The poorest sections of the population, who depend on access to natural resources, suffer the most whenever population pressures are linked to resource shortages or environmental degradation. Government initiatives in the upcoming years will play a critical role in determining future demographic patterns. Understanding the population dynamics of each nation is key to ensuring a better future for each individual.